is like the posterior. I mean, okay, and then we use the Bayesian Bayes theorem, okay, to write it down, right? And then, okay, we know our prior is beta distribution, right? And we know our likelihood is binomial likelihood. So here, okay, you see, in this slide, okay, we put in this beta distribution here, and we put in the binomial likelihood here. Okay. As for the denominator, we know nothing about it. The only thing we know is it is constant, right? As I already described. Okay. So we put in these two things, okay, and we can obviously, see that, okay, there are theta and 1 minus theta terms, okay, from both like prior and the likelihood. So we can, rearrange them. We can rearrange them to become something like this, right? Z plus a minus 1, okay, theta to a z plus a minus 1 times 1 minus theta to the power of n minus z plus b minus 1. So from here to here, it's very basic mathematic, like a massage for the equation. Okay, really nothing very special, right? Okay, so far so good, right? So this is what you have. And this is the denominator will be capital B, AB, which is like the denominator of the beta distribution, okay, with AB as its parameters. And Z, P of D, okay, P of D, this is the evidence or normalizing term that we don't know what that is. Okay, but one thing we do know, BAB is also a constant, right? Okay, BAB, where is this BAB come from? The BAB actually come from here, right? This one. This is our BAB. The gamma A times gamma B, or gamma alpha times gamma beta. This is, normally we describe it as like a BAB. Okay? So this is obviously a constant, right? This is obviously a constant. Okay? Yeah. Not exactly. I mean, it's actually should be. Let me take it back. The BAB should be it should be the BAB is gamma A gamma B gamma A plus B. Okay, this is BAB. Well, we don't know what that value is. Okay, we know, of course, we know gamma is a gamma function. Okay, that we described earlier. Okay, so these terms obviously, are only dependent to A and B, right? And A and B are constant. Remember, A and B are constant. Okay, it's the fixed value that we use for our prior to describe our prior. So A, B are fixed. The data is fixed. A, B term in the prior are fixed too. Okay? So this thing, okay, even though, I mean, of course we could calculate the value here. Okay, we could do that, but we don't have to, okay? After all, I mean, the only thing we need to know is that this is a constant. Okay? So, okay, back to here. So this capital BAB is a constant. And this P of D, okay, is constant too, right? The numerator, okay, contains the terms that are correspond to theta. So these are not constant. They are not constant. Okay. So from here, okay, suddenly it become this. So remember what I say, like this slide, this slide, okay, is actually, except the last step. All the other part in this slide are very easy, okay, straightforward. Okay, the beginning part, well, you just use Bayes theorem. And then you plug in your beta distribution, you plug in your binomial likelihood, and you massage your formula to become like this. And then why you have this? Okay. You wonder how come this term become this one directly, okay? Here I'm telling you, it has to. It has to. Why? The only step that is magical is the last step. And that last step has something to do with the fact that the posterior is the distribution. Okay, so here okay. Let's consider this. Okay, well, your P. Posterior it should be theta D. Anybody has question with this formula? We know posterior is a distribution, right? Over theta, right? Posterior is a distribution over theta. Then, okay, because this is posterior, right? It's quite lengthy, and this formula looks quite lengthy and complicated. But we know it represent posterior distribution, right? Nobody have question about that, right? So, okay, let me plug in that formula to here. Okay, it should be, okay, I can even write the lower and the upper, limit, okay, for the integral, okay. It doesn't matter actually, okay. And then we just theta to the power of z plus a minus 1, okay. Z plus a minus 1, okay, times 1 minus theta to the power of n minus z plus b, n minus z plus b minus 1, right? Okay, and then divided by the capital B AB times P of D. Let me just abbreviate it as D. Okay, and then don't forget we need a d theta, right? I mean, actually, it doesn't matter. I mean, you put like a 0 and a 1. I mean, it doesn't matter. Let's not be distracted to those like a detail. So far, so good, right? Right? And so we know this is 1, right? Right? I say the integral of the posterior is 1. So this is posterior. The integral over the theta is 1. I'm doing exactly that, right? And I remember I keep reminding you, the denominator is constant, right? The denominator is a constant, right? So it doesn't matter. We can put, if when you do integral, okay, if the function has a constant, you can get the constant out of the, the integral. Everybody know that, right? Even though you may already forget how to do integral. You at least I expect you guys still remember that, right? You can put this thing, okay, outside of the integration. And then the thing you left will be z plus a minus 1, okay, times 1 minus z, okay, and n minus z plus b, I'm sorry. Minus 1, okay, and d theta. Right, this one is this one, right? Right? And because this is 1, right? So we know this integral will be exactly this value, right? In order for the result to be 1, this integral will be this value, right? Right? Otherwise, how can it be 1? Right? So, okay, so I can, I can directly write it to be something like this thing is this integration, right? So far, so good, right? Okay. Now, let's consider the beta distribution where we use z plus a for the parameter a and n minus z plus b for the parameter b. Okay, let me this one. Okay, let me rewrite it like okay. Let me get rid of this. It's probably easier to that we use beta distribution. Okay, beta distribution. Let me just use beta. Okay, with like A, B. Is what? Is theta A minus 1 times 1 minus theta. Okay, B minus 1. And then remember I say the rest of the term is BAB, right? 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 So far so good, right? And I told you this is a beta distribution, right? So now, let's think about this. When we put, what is this thing? We put this one as our new A, Z plus A as our new A, Z plus A as our new A, and then N minus Z plus B as our new B. Obviously, these two new parameters are still valid parameters, right? Are still very parameter. I mean, we actually increase the value of A and the B, right? N minus Z, by the way, N minus Z represents the number of